Books open to page 149. And your homework was to do the practice numbers 10 and 17. And then on page 151 at the top of the page, you did numbers 20, 22, 23, and 24. We'll start by looking at page 149, the 10 and 17, and then we'll move to the other page, those other 4 problems that I did give thee, forsooth. So you have inspired me, Genesis.
Indeed.
There they are. Let's see, I feel like we're missing something. We're missing a lot, actually. Missing Abigail. All right, number 10 from the homework. And we were given this inequality here. Obviously, we see fraction and we see inequality symbol. So how would we describe this inequality? This is a, Brandon? Rational inequality. The key to rational inequality is to start by setting it to 0. So we need to move the
12 over x plus 4 over x negative.
To get x minus 12 over x plus 4. You could have moved to the other side, but we kind of came to the conclusion that if we'll move the fraction, generally speaking, it allows us to not have a negative squared variable later, because the next thing we've got to do is get the common denominator, make it into one fraction. So Maddie, now what?
You drop the 1 and put x plus 4, and then on top you put x squared plus 4x minus 12.
Good. This already has the denominator of x plus 4, so we don't need to do anything to my negative 12. Just leave it as a negative 12. Here, this is technically over 1, so we would have had to multiply it by an x plus 4 and multiply this by an x plus 4. But of course, Maddie's smart, so Maddie's like, I can do all that in my head. I don't need to show any of that. And got the x squared plus 4x minus 12. Hopefully, most of you are about in the same zone as well. Even if not, we get to this point. Once we've got a solitary fraction set, in this case, unequal to 0, what then? Audrey? Okay, so for the numerator, we're going to factor. So we could say that 0 is greater than or equal to
X plus 6, x minus 2.
All right, and of course the denominator doesn't need a factor, it's just x plus 4. And this allows me to get my critical points. From the numerator, I'm going to get 2 critical points, Michael.
Negative 6 and 2.
And then from the denominator, I'll get a single critical point.
Negative 4.
The only reason to keep them separate is because the denominator critical point class always is open dot, which means parentheses when we come to using it as our separator point in the ranges. Whereas numerator will take on whatever the actual symbol says. In this case, the numerator class will have brackets and closed dot if we were to graph it on the number line. So I've got 3 separator points. That's going to give me 4 ranges of values. Genesis, let's see if we can do this, remembering that this is going to be parentheses, these are going to be brackets. What are my 4 ranges going to be?
Negative infinity to negative 4.
Well, what's the first number numerically as we're looking here?
Negative 6.
Negative 6 would be the first number we'd come to.
And then negative 6, negative 4. And then negative 4, 0.
Well, 0 is not one of my points.
Oh, negative 4, 2.
Good, and that means 0 can be one of my test values, which I actually really like.
And 2, positive infinity.
There we go. We're obviously going to use parentheses on the infinities. We said anywhere we see a negative 4, that's also a parenthesis. Anywhere we see a negative 6 or 2, that's a bracket. And so there's our 4 different ranges. And then from there, we just got to go back to the original inequality and try plugging in some numbers. I'll start with the 0 from the negative 4 to 2. That drops this out and gives me a 3 is greater than or equal to 0. Is that true, class?
Mm-hmm. Yep.
Yeah, absolutely. We can try a 3. That gives me 12 over 7 is bigger than 3. Is 12 sevenths bigger than 3?
No.
No, so that rules this out. Let's try a negative 5. Negative 5 plus 4. So 12 over negative 1 is greater than or equal to negative 5. Negative 12 is greater than or equal to negative 5? No. So since I've got a no, yes, no, what am I expecting here?
Yes.
Let's just go with a yes. And now again, if we want to make sure that we didn't accidentally mess some other check up, then actually testing a value would be advisable. But we're lazy for the sake of time, we'll just circle it. How many have that answer? On number 10. All right, and then Kendall, I'm going to direct a lot of my questions to you. Questions on that. Feel like you've got the idea. Does that look somewhat familiar from what you watched on the videos, or you were too groggy for this to even look familiar?
looks familiar.
Oh, okay, well, that's a good sign. That's a good sign. All right, so I'm going to have you help me with the next one, the number 17. We're going to follow roughly the same process. So, number 17, we had, except big numbers this time, negative 12x, negative 13 all over negative x plus 3 is greater than or equal to x positive 9. I will say there's an awful lot of negatives there, so I am almost tempted, to be honest, to take care of all this negativity. Here in the top class, we could factor out a negative to make both of these. And then here we could also factor out a negative to make this and this. And then my two negatives. All right, it just cleans it up a little bit. So, or if we wanted to rewrite it, which I don't know if we do, but we're going to do it anyway. It looks like this, and that just looks better. Having fewer negatives showing, just, I don't know, messes with my mind, I suppose. So now what do we need to do, Kendall?
You set it, I guess, equal to 0.
Good, or whatever the symbol is, greater than or equal to, like, whatever. You put a 0 on one side, and which side do you want to be a 0, the left or the right?
Left.
All right, so we're going to put the 0 here, which means the entire thing moves over and becomes negative all of that. So we have x positive 9 minus 12x plus 13 all over x minus 3. All right, and it would help if I put the x plus 9. Yeah, I think that might help with the next step. So we're going to, once we've got everything over on one side, now we're going to take the entire thing and make it all one big fraction. So we'll keep the zeros greater than or equal to, kind of moving up here. One big fraction. Obviously, what goes under the big long line?
X minus 3.
X negative 3. And so in the first fraction, we're going to need to multiply the top and the bottom by
X minus 3.
And that means right here, I'm going to have to do what in the numerator?
FOIL.
To get?
X squared. Positive 6x. Negative 27.
And then what about here in this second fraction?
Nothing changes.
Nothing changes, but except, at least not because of the denominator, but because of this negative sign, what do I write in my numerator?
Negative 12x, negative 13.
Good, both signs change, negative 12x, negative 13. We should do a what in my numerator now?
Combine.
Yeah, let's make it smaller, easier to look at. And so we'll keep the x squared, let's combine our x's.
Negative 6x.
And combine the numbers, constants.
40.
Good. So, and then if we want to, we could take this and factor it into
X and x. Positive, negative.
She's thinking, she's like, not 5 and 8, not 1 and 40, not 2 and 20. So one other way to factor a 40, a 40,
4.
and
10.
4 and 10. There we go. All right. Hey, it's coming off 2 days of being sick. And I'm just happy she's here at all. All right. So that gives us 3 critical points, though, Kendall. My numerator critical points,
Negative 4 and 10.
and then my denominator critical point.
3.
3. So, again, remembering that this is going to be parentheses, these are going to be,
Close.
so,
Bracket.
brackets. What are my 4 ranges formed by these 3 separator points?
Negative infinity to negative 4. Negative 4 to 3. 3 to 10. And then 10 to infinity.
All right, and then tell me the parenthesis bracket thing to put on.
Parenthesis and bracket. Bracket. Parenthesis. Parenthesis. Bracket. Bracket. Parenthesis.
All right, it seems like there's a pattern in there somewhere. All right, and so we're going to test some numbers here, Kendall, and I guess we already mangled the original, so it's going to be hard to use the original, but that had so many negatives anyway. Now, you're not going to use the original, you better be really sure you didn't screw it up, but we were careful, right? We factored negatives cleanly, we canceled those 2 negatives. So we're going to go here to plug these in. What's the first number you want to use as a test value?
Negative 5.
All right, so if we try that, right here this becomes
Negative 60.
plus 13.
73.
Ooh, Ooh, negative 60, positive 13. Negative 47. And then negative 5, negative 3. Negative 8. And of course, these two negatives are just going to cancel. So it becomes 47 eighths. That's almost 6, right? All right, is greater than or equal to, and then negative 5 plus 9.
4.
Is almost 6 bigger than 4? Next number.
0.
Love it. And so when we do, of course, all of this cancels, just hit 13 over negative 3 is greater than or equal to, plug in a 0. Here I just get
9.
Is a negative, which is what this will end up being, bigger than a positive 9? Certainly. Now, we didn't expect it to work anyway. The real question is going to be this next number we try.
4.
Because this will tell me whether we're doing outside, inside, or alternate. So let's try a 4 here. This is going to give me
42. Yep. 60.
4 times 12 class. 48 plus the 13. Does it give me a 61? And then the 4 minus 3, back to Kendall.
1.
So 61 over 1 is just 1. Is greater than, and then 4 plus 9.
13.
And obviously 61 is considerably bigger than 13. So this one does work. So what's our verdict on the last range class? I'm going to give it a no. And how many had this answer on number 17? Uh-oh. Nobody. Okay, check my answer key, make sure I didn't screw something up. Nope, that's what my adjusted answer key has. It didn't say that originally. I had a parenthesis on the negative 4 and I had to fix it because it should be a bracket, but you know, they're human too. Questions on this? Questions? All right, turn over to page 151. Page 151. Let's take a look at numbers 20, 22, 23, and 24. Working with some polynomial inequalities, and then we'll also look at a couple more, I believe, rational inequalities, if my memory serves me right. 23, yeah, a couple rational in there. All right, so starting with number 20, we've got an x cubed, positive 4x squared, positive x, negative 6 is less than or equal to 0. And what do we have to do here, Genesis? Right, I can't group it, so I'm stuck with PQ method. So the first number we always try,
1.
Let's give 1 a try. And when I plug in a 1, I get
1 plus 4 plus 1 minus 6.
And does that equal 0?
Yes.
So first try we got it. So we're going to take the 1. If we wanted a factor, we'd say x negative 1 remembers the factor. But we're going to take the root, the 1, and list out all the coefficients, bring down the 1, we multiply to get
1.
Add to get, multiply to get
5.
Add to get,
6.
multiply to get
6.
Add to get
0.
0, and we're going to fill in our gaps with
X squared. X.
then what?
Factor. X plus 2x plus 3.
And outer inner checks. So if these are all my factors, what are my separator points?
1, negative 2, negative 3.
All right, so be careful here. What are my 4 ranges of values, Brandon?
In parentheses, negative 3, bracket, negative 3, comma, negative 2, bracket, negative 2, comma, 1, bracket 1, comma, infinity,
Parentheses.
Yeah.
All right, and so you get all these different ranges of values, and what's the first value we're going to test now, Brandon?
0.
All right, which is going to fall into this range. Bam, 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 negative 6 is less than 0?
Yes.
Yes. All right, next number you want to try?
2.
2. So in that range there, cube it, square it times 4,
60.
and then another 2 minus 6 is less than or equal to 0? No. Next number.
Negative 4.
Negative 4, we're going to skip the little range there, and cube it.
64.
Negative 64, square it times 4.
Positive 64.
And so those are just going to cancel anyway, and that gives us a negative 4 here. Negative 6 is less than or equal to 0?
Mm-hmm.
Yes, and so Verdict on the little range?
Don't-
Nope. And how many got that? Questions on that? Kendall, questions on that? All right, I think you were here the first day we did that at least. All right, questions? All right, let's take a look at number 22 right below it. So 4x to the 4th, positive 2x cubed, negative 12x squared is not greater than or equal to, just greater than 0. And Maddie?
2x squared.
Good, and that leaves us with what in parentheses?
2x squared positive x negative 6.
All right. Greater than 0, then?
You get factors. And then you get x negative 1, x positive 3.
X negative 1, x.
Wait.
I think something's not right.
It's supposed to be a 2.
All right, so
No,
let's.
it's not. No, it's not.
Well, let's regroup here.
No.
Let's take it in small steps. How do we split up the 2x squared?
The x and the 2x.
Okay.
And then the negative and the positive are 1 and a 3.
A 1 and a 3? A 2 and a 3?
Maybe.
Let's go with 2 and 3. Let's check your outer inner though and see if it's right.
No, you switch the sign.
Just switch the signs. All right, so we're there now. All right, and so we're going to have 4 critical points. What are my 4 critical points though?
0. And then another 0. A negative 2 and positive 6. Nope. A positive 3 over 2.
Right, we get 2x equals 3 when you move the 3 over, then divide away the 2, so a 3 halves or a 1 1/2. All right, so what are my 5 ranges going to be?
A negative 3 to a negative 2. And then a negative 2 to a 0. And then a 0. And then a 0 to 32. And a 3 to 2 to 3.
Great job. Of course, we'll use parentheses on these, and for that matter, we'll use parentheses everywhere. All right, one of these ranges we can immediately discount. The 0. Because you can't, if 0 to 0 but not 0, like, it doesn't even make sense, right? So forget it. So let's try some test values then. Let's go to Audrey now.
A negative 1.
All right, we plug it in here. That gives us 4. Plug it in there.
Negative 2.
And then there
Negative 12.
is greater than 0?
No.
No. All right, let's try another value.
2.
All right, to the 4th, times 4.
64.
Cubed times 2. 2 cubed
8.
times 2.
16.
There we go. 2 squared
4.
times negative 12.
Negative 24. 48.
Negative 48. Greater than 0?
Yes.
Yes. Okay, so this works. Another value.
Negative 3.
Now, I will point this out, class. A 1 would be an easy number to try, right? Because 1 is between 0 and 1 1/2. But very rarely are adjacent ones going to be equal, right? Unless it's like insides outside. So if it's alternate, this wouldn't work, and if it's insides outside, so I'm probably not thinking it works. So I'd probably try the 1 first. But let's go with the negative 3. Let's raise it to the 4th. 81 times 4.
Negative 24.
Hey, see, I mean, we could do it. All right, and then cube the negative 3.
27.
Negative 27 times 2.
54.
Negative 54. And then square the negative 3
9.
times negative 12
108.
is greater than 0.
Yes.
Yeah. And so, again, I'm really not expecting this to work. If I wanted to, just plug in the 1 that's going to be 4 plus 2 minus 12 is greater than 0. It does not work. There's my answer. How many had that for number 22? Questions on 22? All right. And it was factoring that got you. Okay. All right. Looking at numero 23. Oh, this one's really, really easy. So, look at this one to Michael.
Hey.
Michael, everything's done for us. It's already to 0. It's already a single fraction. I'm just ready to get my numerator and denominator separator points.
6 and negative 5.
And get my three ranges.
Negative infinity, negative 5, negative 5 and 6, 6 infinity, and beyond. That's all parentheses.
All right, pick a number, any number.
0.
0. Is that true?
No.
No, it's a lie. All right, pick another number.
10.
Minus 6.
That's 4.
10 plus 5.
15.
Is that bigger than 0?
Yes.
It's not much, but it's bigger than nothing. And so what are we expecting to happen there?
Yes.
Yes. We can gamble and just say yes, and it is. I already got that for number 23. Questions 23? And number, yes, 24. We had negative 6 over x negative 5 less than or equal to x. And Genesis. What doeth we? Or what oughtest we to do? Pursue.
Set it equal to
So let's bring our book to class. What?
set it equal to 0.
All right, which side?
Left.
Put the 0 over here. Less than or equal to x.
Plus 6 over x plus 5 minus 5.
There we go. Because this negative, we move it out front first. It's a negative this, so when it moves over, it becomes a positive that. I'm also going to put the x over 1 so that when I draw my big long line and put
X minus 5.
below it, I know that what's going to be copied above the line.
X negative 5x plus 6.
There we go, because we're multiplying top and bottom by the x negative 5. And of course, we'll want to do what with the numerator polynomial? Factor it. So we say that 0 is less than or equal to
X plus 3x minus 2.
right about the x and x. What about our signs?
Oh, same. Minus.
But you are right about the 3 and 2, though if they had been alternate, we would have needed a 6 and 1 to get the 5. All over x negative 5. And so 3 separator points for the numerator
3 and 2.
and for the denominator.
5.
5. All right, so what are my 4 ranges, Kendall, formed by these 3 separator points?
Negative infinity 2. 3, nope, 2 first. And then 3, 5. And 5 to infinity. And then bracket, x, and then x.
There we go. And so we pick a not so random value. Oh, we're going to come back here, back to the original. All right, Kendall, pick a not so random number.
0.
And if I plug in a 0 here, that gives me 6 over negative 5, or in other words,
6
is less than 0?
no.
No, positive 6 is not less than 0, so this drops out. I don't want to try that. Let's go to this one. Pick
4.
the only decent integer to try, and just to plug a 4 in right here,
Negative 1.
but it's negative 1 or just,
Positive
so we end up with
6.
6 is less than or equal to 4.
No. Wait.
And then try a number bigger than 5.
10.
All right, so 10 minus 5,
5.
but it's negative 6 over 5 is less than or equal to 10?
Yes.
Yes. So what's our verdict on this one that we didn't want to try? That would be a yes. How many had this on number 24? Questions on this? Any questions at all on the homework? All right, just have your notes out. You can set your books aside for a little bit, and let's do some more practice with a variety of these different problems. Kind of a recap of all these different inequalities we've been working here. Particularly beneficial for those of you who don't have books readily accessible. is kind of weird on the first one. I wasn't actually kind of prepared for that. But we get 2 -2 separator points. How many found that? So therefore, -2 to -2 is its own range in this problem. Kind of like we've had that happen with the 0 before. And so I was like, oh, that's different, okay? But there we go. Any questions getting to this point? Any questions getting to the 3 separator points? All right. Well, that's also not what I was expecting. And you get all 3 in a row ranges working? Yeah. Alright, so that's weird. Alright, but alright. It's one of those it makes me like, did I mess something up? But all y'all got the same thing, so it's not just me. Alright. That makes me feel better. Unless Gavin emails me later and tells me, well, actually, Mr. Esky, you forgot this. Or Abby, whoever gets to email first. All right. Any questions on this? So this was a little different than what we normally were, because I'm used to insides, outsides, or alternates, and here we went. Of course, granted, it's a little weird because this was its own range by itself, but still, weird that it worked. And if it had been no or equal to, right, then it wouldn't have. Then it would have alternated them. So maybe that makes more sense. It's because of the or equal to that it was able to work, and those 3 in a row work. Questions? Keep working. Wake up, Jesus. Yes, sleepy.
I'm squinting.
Oh. Use your glasses.
She was imagining where her book was.
I know where it
She was that
is.
deep in thought Yoda look, right? Cloudy the future is. Calculator. I can't do it 16 times 18 in my head. Surely it works. Come on, surely. Yeah, it does. Does anyone still need this first problem left on the board? Everyone would go with that first one? Most of you are good with all 3, but I'm going to erase this first one and put up another one for you. Any questions on the second problem? Any questions on the second problem with the 2 outers and working the 3 inners not? Looks like we're all past that second one. So I'll erase it and put up a different one. Any questions on this third problem here? Just a straight quadratic. Questions on this one? Go ahead and erase. Anyone need it left up? For sake of time, these last two, I'll just have you check your work, check to see if you're on the right track here, if you weren't already finished with them. Any questions on these? We spent a lot of time the last couple of days on these here, so for sake of time, we'll go ahead and end with this. But questions on these? How many either got them or were on the right track? Any questions at all on the rational ones? All right, clear desk, except for a clean sheet of paper and a pencil and a calculator. Clean sheet of paper, pencil, and calculator. Everything else away. First last name at the top of your paper along with today's date, which is 12/15/21. 12/15/21, today's date. First and last name, 12/15/21, today's date. And this is quiz 18. Quiz 18. We'll end the video here in just a moment. There's no homework this evening. Quiz 18. Pretty straightforward. There are 7 inequalities. Some are easier than others, so you may choose to go out of order. 7 inequalities. Solve them. That's it. 7 inequalities for you to solve. Be sure to use the quiz copy as a cover sheet. All right, you may get started.